Hi everyone, I'm Advika Radhani and this is my Physics 2212 lab theory about circuits. The purpose was to use the principles of energy conservation and current conservation to predict the behavior of circuits containing resistors in series and parallel. We used multimeters to measure the actual values of conventional current and potential differences in the circuits and examine the behavior of ohmic resistors and capacitors. During this lab, the fundamental principles were used: Kirchhoff's voltage law, Kirchhoff's current law, Ohm's law, and the RC equation. The main results of the lab were the potential difference across the complete circuit, sum to 0, and the measured current was 0.0016 amperes. The RC value was found to be 13.342 seconds. Increasing the resistance in an RC circuit increased the charging and discharging time. For the DC circuit experiment, the circuit was constructed using two 1.5 volt batteries combined to produce 3 volts and two resistors. I predicted the current using the appropriate equations and found a predicted value of 0.02 amperes. However, after measuring it experimentally, the value was 0.16 amperes. When the actual battery voltage was measured, it was 2.7 volts, so the predicted current of 0.16 amperes was closer to the real value. When the connection was resolved, the current measured negative 0.16 amperes, which is consistent with the expectations. After converting to the voltmeter configuration, the ammeter reading was 2 to the 2 to the 8th, which is essentially 0, and the voltmeter reading was 2.8 volts, close to the measured 2.7 volts. So for Kirchhoff's voltage law verification, the battery voltage was 2.7 volts. The measured potential differences were 0.859 volts across the 47 ohm resistor, 1.88 volt across the 100 ohm resistor, 0 across the wires, and 0 volt across the ammeter. So substituting into the Kirchhoff's voltage law, we got the voltage to be very close to 0, which is what the Kirchhoff's voltage law predicts. So now calculating resistance of each element using R is equal to V by I equation and the measured current of 0.16 ampere gave us these differences because the components were not ideal. So now the RC circuit experiment. Next, an RC circuit was constructed with a light bulb to visualize charging and discharging. The observations: the bulb was bright initially, then slowly dimmed as the capacitor charged. When the capacitor discharged, the bulb briefly became bright again, then quickly faded. The 10 ohm resistor had shorter charging and discharging times compared to the 20 ohm resistor. Determining the RC time constant. So now the RC value was found using the RC equation and the fact that voltage was 0.38 of the initial voltage after the one-time constant. Charging and discharging values were calculated for the 10 ohm resistor and the average value was produced. So now there were some assumptions in the lab, which were that the circuit was ideal, the circuit was in a steady state. This allowed Ohm's law and Kirchhoff's law to be applied. So now the possible errors could have included that the circuit components were not new, so the battery voltage was 2.7 instead of 3. The timing measurements of the capacitor charging and discharging were not perfectly accurate. So now for the what if question. In a real circuit, if there was no resistor, the wires and battery would have still remained in internal resistance, which prevents the capacitor from charging instantly. If the circuit were ideal with absolutely no resistance, the capacitor would charge instantly. However, this cannot happen in real life because there is always some resistance present in any physical circuit. Thank you so much for watching.